In the topic box plot, it's a diagram to represent the spread of information. Usually a box plot contains, it's a shape like this, and there's another term for box plot is Visca plot. Visca plot. So there's a slight difference between box plot and a Visca plot, but in our level, we don't see much of a significant difference on that. The shape of a box plot is just like this. It's over here, just like this, and below you can see a number line with that. Okay, below you can see a number line with that. So what are these lines and what are these values? What are these figures?
Sir, isn't that a resistor, sir?
Children, what is it?
Nothing, sir. Nothing, sir.
Right, okay. Then in this case, this value is the lower boundary, LB. This value is the lower boundary. LB means lower boundary. Lower boundary. And this is the upper boundary, right? It's a upper boundary. Upper boundary. And this value would be the Q1. Q1, this is median or Q2, and this is Q3. These are the basic shapes, we are basic context to mark in a box plot and the order Visca plot. Now we need to see whether how to draw a box plot for given set of data, and how to identify the proper boundaries, and if any outliers are there. So you can mark the outliers if available only. Other than that, no need of marking the outliers. Process you mark by the outliers. Outliers would be the which answer that is marked by the crosses. Right, now let's see how to work out in the box plot. Right, okay, let's go ahead with this. Right. We'll get a one initial set just like this. We'll get 20, 21, 23, 24, 24, 26, and 27. Right. So in this case, what you can get here is, this is the value what you gain by the median, Q2 or the median, right? Then we can understand that this is the value what you gain by Q1, and this is the value what you gain by Q3. Hope there is no problem how I get this Q1, Q2, median, and the Q3. If you have any doubt, please raise your hand. Right, seems to be there is no doubt. So in this case, you can get the lower boundary by Q1 minus 1.5 times of Q3 minus Q1. This is the usual formula for lower boundary. Right, okay. Then what you can get here is a Q1 is 21 minus 1.5 times of 26 minus 21. So this would be 26 minus 21 is 5. 7.5, 14, 13.5 would be the answer for the lower boundary. But when you're defining this lower boundary, this is the point we need to understand that. This 13.5, take this thoroughly into your mind. 13.5 is the minimum possible value. Which is accepted. But
so sir,
yeah, so
if it goes below 13.5, does it mean it's an outlier?
It's an outlier, exactly. 13.5 is an outlier, but the fact we need to understand is that means up to 13.5 we can consider it's a reasonable value for a set. But what is the available minimum value in this set? It's 20 now. But the minimum available value is how much? Value is 20. Therefore, lower boundary is 20, and no need of worrying about this 13.5 at all. Right. If you come across anything which is lower than 13.5 only, we have to consider the 13.5 is an outlier, is an lower boundary, and mark the 13 as outlier. I will do one question similar to that extent. Right. We will go ahead with that. Then the lower boundary. Okay. Lower boundary is Q3 plus 1.5 times of Q3 minus Q1. Right. Okay, that's great. Then Q3 is 26 plus 1.5 times of 26 minus 21. It's 7.5. 26 plus 7.5 is 33.5, right? Okay. Now this is the maximum possible value which is accepted, right? But what is the maximum available value over here? But the data set is ended up with 27, which is within the range. But you can say, but the maximum available value is how much? What is the maximum value available here? Sorry, it's only 27. Eh? It's only 27. It's 27. Therefore, upper boundary would be how much? Upper boundary is 27. 27.
Sir,
Yes. Okay. Yes. Aflal.
then why are we using equation to find the upper boundary? It
Yes.
is straight
No.
away 27, no?
I'll come to that, Pute. Yeah, that is correct. What you asked is exactly correct. That means, Pute, that is to identify the limitations, right? But with the existing set of information only we have to define. So at the next level of question, you will understand that what is the point of doing this calculation. Okay? Right, we'll go ahead with this. Now you can see now the box plot. The lower bound is 20, upper bound is 27, and these ones are the quartiles available here. So in this case, we can mark the box plot. Right. I'll just make the page, we will do double pages, then I can draw it. So initially, what you need to do is you draw a number line where the figures are available up from 20 onwards. 20, 21, 22, 23, 24, 25, 26, and 27. Right. So in this case, the lower boundary is how much? 20. In the next question, Patel, you will understand what is the significance of this 13.5. 21, Q1 is 21. Q2 is 24. Q3 is 26. And Q7 is 27. Right, okay. Then we can draw the box plot in this way. That is the answer for this question. Right, okay. Right. Then we will come up to, that is the example 1. This is the example 1. Right, okay. Then we will go ahead with the second example. From the second example, you will clarify with most of the questions you raise in the you come across, and when you're doing this first question, it's turned up to 13. 13. I'll just mark these ones just like this. 13, 21, 23, 24, 24, 26, and 27, right? Okay. Then we'll come up with this. Right. Then we know that this is the median. This is the median, Q2, and this is the first quartile. Q1, this is a third quartile. Q3, sorry, in this case, you can say Q1 is 21. Q2 is 24, the median M, and Q3, third quartile, is 26. Then if you get the lower boundary, now this is the point you to understand that. 21 minus 1.5 times of 26 minus 21. Now you get the answer how much? 13.5. Now focus on this answer, right? Lower boundary is 13.5. This is the point you need to understand. That means in this set, we can consider the minimum value of 13.5 as a value which is reasonable to consider it is in this set. But you can see there is a value less than 13.5. But there is a value less than 13.5. In such cases, we consider 13.5 as lower boundary, and what happened with it? 13 become what? 13 become,
Minimum value.
yes, outlier. 13 become outlier. So 13 has to be ignored. In that situation, we consider lower boundary as lower boundary as the 13.5. But in this case, when you're concerned about this case, what is the condition? Though the lowest value is lowest accepted value, lower boundary is 13.5, in our set, the lowest value is not less than that. In that situation, no need of going ahead with this much of a lower value. You can end up with a lower boundary as 20. That is the condition we should thoroughly understand in this question. Is that clear, the difference between these two questions?
Yes, sir.
Yes, right. Okay. Then we'll come up with the upper boundary. Upper boundary is 26 plus 1.5 times of 26 minus 21. That answer is 33.5. The same answer what you gain over here. I am using the same set of information, just make a slight changes. But what is the condition, Pute? But you know that we can go up to 33.5. But in our set, data ended up at where, Pute? Data ended at 27, Pute. But the highest value in the set is 27. Therefore, what happened, Pute? Then no need of going up to this much of extent for the upper boundary. Then you can say upper boundary is how much, Pute? Upper boundary become 27. Okay, let's go ahead with this.
7.
Then we need to draw the box plot, Pute. So when you draw the box plot, Pute, we should be able to mark 13 and the upper boundary of 27. So it should be 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. Then what is the lower boundary? The lower boundary is 13.5. So Meka, when you mark it today, it's not, if it is not in the number line, we need to mark it clearly. 13.5 is the lower boundary. The Q1 is 21, it's here. Q2 is 24, it's here. Q3 is 26, it's over here, and the upper boundary is 27. So you can mark the this is the way. Up to this extent, if any area is not clear, please raise your hand. Up to this extent, if any section is not clear with you, please raise your hand. Yeah. Seems to be not. Right, okay. Yeah, okay. Now let's go up to the next question. We'll get another set of data, which is little bit similar to this. Yeah, I'll get this set of data there. I'll just get 16, 21, 23, 24, 24, 26, 35. Right, okay. Now, right. Now let's go ahead with this. Right. When you're finding the median, the first quartile, we need to find the median and the third quartile. Right. The median is here, 24. The first quartile is 21, it's here. And the third quartile is 26, it's here. Right. Okay. Hopefully, that's the same like mechanism we used in the previous questions. Then we need to consider the lower boundary. Lower boundary. What is the lower boundary over here? Lower boundary is Q1 minus 1.5 times of Q3 minus Q1. That's the answer for that. So it's turned up to 21 minus 1.5 times of Q3. Q3 is 26 minus 21. It's turned up to how much? 13.5. Now That means that you can go up to 13.5. Now look into the data set. What is the minimum value available in the data set today? It's 16. Is it less than 13.5?
16.
No. So what is the lower boundary? Now tell
Yeah.
me what is the lower boundary?
16 is the lower boundary.
16 is the lower boundary, not 13.5. No need of worrying about this 13.5 anymore, because the what you call the data available in the set is more than the minimum value, right? That's not a problem with that. Then the upper boundary is Q3 plus 1.5 times of Q3 minus Q1. So in this case, Q3 is 26 plus 1.5 times of 26 minus 21, it's turned up to 33.5. But what you can see now, but the highest value available in the set is how much?
The
35. Now what is the lower bound, upper boundary then?
35.
Then the upper boundary becomes
33.5.
5, and what happened to the 35 is an outlier. 35 is an outlier. That is a theory we need to understand.
Sir.
About. Draw in the box plot. Yes, Pate, what is it?
What are cases like the 1.5 will differ?
Sorry, Pate, I didn't get it. Afla?
What
Like
are
does
the
the
cases when that
1.5
1.5
differ?
will differ?
I didn't get it clearly. One of you please ask question clearly. Afla, what is the question?
Always we must use the 1.5, right?
No.
When will it
But
differ?
1.5 is the significant.
When will that 1.5?
No, yeah, that's correct. 1.5 is a general value, right? But if they not specifically mention up which extent you need to use, you can use 1.5. Okay, but there are some situations we just narrow down and we just trying to extend this information. In that conditions, they used to say what is the figure to be used. There are some situations you use 2 instead of 1.5 or 1.8, 1.75, 1.25, sometimes only 1. It depends on the set, but unless if they, yeah.
Like, what does
Yes.
that 1.5 or 2 means?
Means like we consider from the quartile up to which extent to the lower side or up to which extent to the upper side, we consider the data set is reasonable. That is the physical meaning of that. That means from first quartile, we consider 1.5 times of interquartile range, the middle range of data we consider as the lower boundary. Yes, that is reasonable, right? That is a significant way of understanding this question, and there are special statistical distribution process we follow up to define this formula, right? But practically up to that depth, we won't learn in this S1. But lower bound and upper bound, that's a physical meaning for that. Actually, there's a physical meaning. Why do we consider this 1.5 of this quartile? But in our level, we don't go that much of depth, right? If you want to learn, you can learn statistics in your university level. There we learn what is the reason. Why do we get this 1.5 range of one interquartile range as a lower boundary and the upper boundary from first quartile to the lower side and third quartile to the upper side. But for the moment, you just consider it is as it is, right? If you want, I will send some kind of a video regarding this, but I don't think that it's a little bit of a complex. That is why we won't go that much depth into this theory. Okay, right. Then let's try to draw the what do you call that, the box plot or the Vizca plot. Then what is the lowest boundary? The lowest boundary is 16. So we need to draw up to 16 to 35. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35.
Sir, we don't need until 35, no, sir.
Sorry, sorry, but we had, it's an outline, so we need to mark it.
Okay.
Is that clear? The lower boundary is how much? 16. First quartile is 21. Median or second quartile is 24. Third quartile is 26. And the upper boundary is 33.5 here. You have to mark this value as 33.5 and draw the box plot. And we need to mark what? We need to mark this outlier. 35 is an outlier, so to mark it from across. That's what we did in the previous question as well. Here, but I didn't mark me.
So don't need to mark 13.5 outlier.
Here, but you need to mark me. 13 is an outlier. I didn't mark it. Sorry, it's my mistake. You should mark this outlier over here. It's a must because the lower bound is 13.5 and it should be marked. That's correct. So I made a mistake here. It should be marked. And here also you should mark the outlier 35, right? That is important. Then only you can understand, because anyway, those who look into this box plot, they should understand about what is the behavior of this graph. So to understand it, definitely if the outliers are available, we need to mark. That is compulsory for us to do it. That's the way of getting this, the fact. Is that clear, children? That's a way of drawing a box plot, right? Right. So that is how you need to learn about the spread of the set of information. Right. Okay. Then we will come up with another important topic, that is the marking the histogram. Right. Now, just let me know how many of you are there in the national curriculum. Those who came after national curriculum, please raise your hands. Let me see who are the students who came for the national curriculum. Samra came from national curriculum. Who else? Only Samra. But Benuri? Isn't it here?
Not here.
Not here. Right. Okay, doesn't matter. We'll start. Okay, Samra, doesn't matter. So we will be doing that, right? Okay. Now, Pate, look at this. This is the point we need to understand in this theory, right? We will get a class. The class, the age or somewhere, we'll get this age. You'll get 6 to 10, 11 to 16, 17 to 25. Then you'll get the number of players. Number of players. We'll get 25, 18, and here we will take 27. Okay. Now let's see. We'll try to. We have already, those who are in London classes now, we already learned this theory, but doesn't matter. Just to review, we will learn this fact. Now let's see, Pate, if you need to draw the histogram, right? The question is, draw a histogram. Draw a histogram. Yes, one of you please tell me what is the difference between a histogram and a bar chart?
Histogram displays the frequency density against the.
Okay, the class.
Whereas bar chart just represents frequency. Yeah.
Yeah. So in this case, that's a one factor of it. So when you're concerned about the histogram, Pate, you cannot keep a gap between the bars unless if there is any area where you don't have the information. Without unless if there are information available in a certain set of area, we cannot keep a gap between the bars. But in a bar chart, we can keep gaps. For example, we will get some information in the month, Jan, Feb, March. This is the frequencies 10, 12 and 8. So you can mark this information just like this. For the January, you can draw the bar like this. For February, you can mark the bar like this. For this one, you can mark the bar like this. You can do it. But in what do you call that? In the histogram, you cannot mark as it is. You cannot mark as it is definitely. Like if you keep a gap between this one, that indicates you in that specific duration or whatever the fact, you don't, the informations are not available. So other than that, you cannot keep a gap between this. That is the fact we need to understand about drawing a histogram, right? Okay. Initially, let's try to draw the histogram. So in this case, there is a gap between these bars. Look at this. Then we had, what is the first step? The first step is you need to adjust the class boundaries. You need to adjust the class boundaries. Okay, this is 5.5 to 10.5. This is 10.5 to 16.5, and this is 16.5 to 25.5, right? Okay, right. Now, if you have any doubt about how I get these class boundaries, please raise your hand. Yeah, hopefully you know how to do this. What you need to do is get this gap and divide by 2. That would be the boundary for this. Get this gap, divide by 2. That would be the boundary for that, and extend the same amount to the lower side and the upper side from this over here. Then initially, let's try to draw this histogram. Right. Okay. Initially, I just mark these values like this. The highest frequency is 27, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28 is the frequency. And the class widths we will get. So initially, I just mark because it's starting from 5.5, 6.5, 7.5, 8.5, 9.5, 10.5, 11.5, 12.5, 13.5, 14.5, 15.5, 16.5, 17.5, 18.5, 19.5, 20.5, 21.5, we need to drop to 25.5 today, 22.5, 23.5, 24.5, or draw it on a proper scale today, 25.5. Now, if you draw this histogram for this, so scale get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and 28. Yeah. For the first category, put the 25. See here, up to where? Up to 10.5. This is the first bar. After that, it come up to 18 today. Up to where? Up to 16.5. Right. After this, come up to 17 to 25. It's 27. We need to draw up to where? 25.5. With this information, what does it implies? So you can see there is a heavy information available in the group of where? In the group of 17 to 25. And the next largest information is a set of 5.5 to 10.5. But literally you can understand that what is the gap over here? The gap over here is only 5. Here the gap is only age gap of 5. There are 25 information. Here the gap is how much? That gap also 5. In that gap, another 18 information is there. But here, what is the gap over here to here? 25.5 to 16.5 is, it's a gap around 9. For a gap of 9 only, you get this 27 information. Therefore, literally anyway, you know that if you increase the gap, definitely, for example, if you calculate number of the amount of score, you know, the amount of what do you call, some kind of patients or number of some information, if you increase the gap, definitely you know that you can get more information on that. To avoid this mistake, what is the technique we use to get it? That is the fact we need to understand. So for that, we calculate the frequency density. For that, we calculate the frequency density. Frequency density. How to calculate the frequency density, Pute? You can
Frequency
divide
over class width.
frequency by the class width. We can divide the frequency by the class width. Right. Let's do this. We'll calculate the frequency density for this. Right. We are going to get this. Then I'll do the first calculation. After that, I will just get it. So I can say 25 divided by where? What is the class width? 10.5 minus 5.5 is 5. Then what is it? It's turned up to 5. Here, 18 divided by 16.5 minus 10.5 is how much? 6. It's how much? 3. Here, 27 divided by where? 27 divided by, here it's 25.5 minus 16.5 is 9. It's 3. So literally, if I draw this, if I draw this for this range, you can understand that. Then but that is the actual behavior of this graph. So you can draw this histogram. I'll use a different color to represent it. Then it's clear. I will mark with a red color. Now, if you mark these ones, we can mark the frequency density. Frequency density comes with maximum is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. From here, you can mark it 0. It starts with 5.5, 6.5. This is 5.5, 6.5, 7.5, 8.5, 9.5, 10.5. I'll mark these ones only, other than that it's kind of not clear. 10.5, 11.5, 12.5, 13.5, 14.5, 15.5, 16.5, 17.5, 18.5, 19.5, 20.5, 21.5, 22.5, 23.5, 24.5, 25.5. 25.5. Sir?
Sir,
Yes, but can. What's it?
we have another class in 4 minutes, sir.
Yeah, we'll quickly. I'll finish it off with it. Just give me a couple of minutes, right? Okay, right. So in this case, this frequency become how much? It's 5. So you can mark 5 up to here. Quickly, I'll finish it. 5, and other than that, it's 3. Up to 10.5 is 3. Then over here, even 3. Now you can see, when you look into this graph, actually the highest frequency available in which category? It's in this category, not in any of them. Here the widths are already, here the frequency densities are already similar. So under that ground, what we can understand is, we need to draw a frequency density instead of a histogram hereafter when you are working out with plotting this information on a bar diagram, right? That is how you need to understand with this concept.